Yes, Gotham.
Perfect. I hope my screen is visible now.
It is. Yeah. Thank you.
Perfect. All right. Let's get started. I'll just minimize this. Okay. So once again, welcome everyone. The goal for today's workshop in general is to first let everyone know what Aleo is and how you can get started with building private dApps on Aleo. So for those of you who do not know about me, I'll give you a quick context on what I do and what I've been up to in this space. I'm a DevRel ambassador at Aleo and also a lead ML engineer at Lucidity Finance. It's a DeFi startup. Previously, I've been an engineer pretty much all my career, and I've been lurking around in DevRel and have also founded a company in the security space. If you'd like to connect, you can scan this QR and just keep in touch. All right, let's get started. So I want to start with basics first and give you a little bit of context. I know most of you understand what blockchain is, but if you look at the concept, it's all about utilizing the decentralized concept of a peer-to-peer network, which we are all aware of, but it was never utilized in this concept of using transactions. I'm just checking if there's anything. Okay, perfect. So ideally, what we are doing in a blockchain is you start with a transaction that is broadcasted into an entire network of all the people who are participating. All of the people in that network need to come to a consensus where they say that this transaction is valid and I'm ready to send it to the next stage where it can be included in a block that can be chained together with all of the other transactions. And that's how a blockchain is formed. Now, multiple blockchains that we've seen so far, the way these people will come to a consensus, the way this transaction will get added to a block, all of this can differ, but the core concept of a blockchain is still going to stay the same. Before we proceed further, for those of you who haven't done the setup for the workshop yet, you can go to this link and do the setup so that by the end of the presentation, you're all set up for the workshop and good to go to do some hands-on activity with me. I can also put this link in the chat for easy access. All right. So a lot of the times when people talk about privacy, zero knowledge as a concept really comes into mind. So if we look at it, what exactly is Aleo? Is it an L1? Is it an L2? Is it another VM that is built on top of Ethereum? No. Aleo is a layer 1, fully private, privacy-preserving blockchain that helps you build end-to-end private dApps. And a lot of you would be thinking that, how is it doing it? So Aleo has its own VM, its own language, its own OS, all of which help you build end-to-end secured apps without having to move to a different layer for settling transactions, or in general, going to another technology or a roll-up for doing the computation of your proof. But when I say proof, what exactly am I referring to? So let's understand the concept of zero knowledge proof. If you look at it, it's not a new concept and has been there for years in the cryptography world. The bottom line here is that there are two very important things that we need to focus on. There's one party, which is the prover, who's trying to prove to another party that a given statement is true while avoiding to convey any information to the verifier, which is, related to the statement. So the only public information that is there is the statement. How that statement is true, we are not trying to tell that fact. Now, if I were to put it in a very simple way, it's all about saying that I know they know, but I do not know what they know. So our goal is to be able to convey the correctness of what we're saying without revealing any secret. For example, verifying that you are above 18 without showing any of your ID is one example, a very simple example of ZKP. Now, I'm not sure how many of you know of this game, but Wordle has been a pretty popular game, especially during the lockdown times, where you have to solve a puzzle every day. And if you're able to get all 5 blocks as green, that means that you were able to solve the puzzle. But nowhere in this entire process, the solution for that day is resolved. So it's a very simple example of how you're able to prove that you were able to solve today's puzzle, but you were not revealing the answer to anybody and anybody. But still, everybody knows you solved it because you have the image that gets generated when you actually solve it. So let's take an example to understand this whole concept of zero knowledge proof. And let's keep it interactive. Would love to hear your opinions. So let's say there are two friends, Bob and Alice, and they've collected a lot of candy over the Halloween holiday. And now they're having this competition between them, do they have same number of candy or not? Because if they have same number of candy, they'll have to share it with each other, which either of them doesn't want to do. So they need to find out whether or not they have same number of candy or not. But both of them don't want to reveal each other's actual candies, because if one has more, the other one will have to share. So what do they do? How do they go about it? Any ideas of how Bob and Alice will be able to check whether or not they have the same number of candies without actually revealing the number of candies they have? You can unmute yourself, you can raise your hand, you can put it in the chat. Any innovative ideas of how you can go about it? Any guesses? Okay, probably I'll give that away. So one way in which both of them can do this is also another information that I forgot to give is that we are assuming that they have either 10, 20, 30, or 40 candies and not any other number. So it's a whole number. So what they decide to do is that Bob gets 4 boxes, each marked with the number of
Hello.
candies that they can. Yeah, please
We
go.
can tell the color. I have 10 red candies. Like that, we can tell.
No, we're assuming that these candies can be any random color, any random size, any random weight. We just know that the number can be either 10, 20, 30, or 40.
Oh, okay.
Yeah. Do you want to take another shot at it?
Maybe
Please go
you
ahead.
can tell that question once again. I
The
can try
question
it.
is, Bob and Alice have certain amount of candies. They are trying to find out if they have the same number of candies or not, but they do not want to reveal the actual number of candies they have. That's the problem statement. And
Okay.
they want to figure out. And to make things easier for you, they can have either of this number of candies, 10, 20, 30, or 40. All right, if there are no takers, let me give you the answer. So one way of solving this is Bob gets 4 boxes, each marked with the number of candies he can potentially have. And what he does is he takes away the key of the box that he has the number of candies for. So we're assuming here that Bob has 20 candies, Alice has 30 candies, which is a different number of candies. So they will end up not sharing any number of candies. So what he does is he takes away the key of this particular box and throws away the other. Now, what do you think Alice can do? Any guesses? Any ideas? Okay, I'm assuming the time of the day. I hope everybody has had lunch, but let me give you the answer. So what Alice does is she takes 4 pieces of paper and marks one with a plus and rest with a minus. Now what she's going to do is slide the paper which is marked with plus in the box that's marked with 30, and in the rest of the boxes she's going to slide the paper with the minus sign. Now, when Bob comes and opens the box marked as 20, he sees a negative sign, which means that he doesn't have the same number of candies as Alice. But how do Alice identify? So when Alice comes and sees the paper in Bob's hand, which has a negative sign and he's standing near the box marked with 20, she can also confirm that Bob and Alice both have different number of chocolates. And this way, both are able to figure it out that they do not have the same number of candies, but in no way they know what is the actual amount of candy they have. Now, while this is a very simple example, in real world use cases, the data will never be this simple. And the computations that we're talking about can be fairly larger or fairly complex. So if you were to talk about zero knowledge proofs from a very technical perspective as to how does this information exchange happen, because this is a simple example, but how do you trust the prover that easily? So essentially, whatever is the statement that we are trying to prove, the prover will have to give some proofs to the verifier based on the challenges. Now, let's assume there are certain public inputs. For example, in the previous case, our public inputs were there were boxes and there were pieces of paper marked with a plus and minus. So this is something which everybody and anybody can see. And then there are private inputs which only the prover is aware of. So when the prover has certain inputs, based on verifier's challenge, the prover will solve a certain mathematical puzzle, send a proof back to the verifier, and he'll make sure whether he's able to come at the same answer that the prover was trying to give based on the public inputs. And this process is repeated multiple number of times so that the verifier can be sure that the prover is not trying to trick the system. But, how do we decide the number of times do we do it? And how do we decide when and how to do it? So there are sophisticated ways of doing it. That's where one of the proving system comes into picture, which is zk-SNARK. So Aleo as an ecosystem is SNARK based. And let's understand what are SNARKs and where do they fit in the entire ecosystem. So zk-SNARK stands for succinct, non-interactive argument of knowledge. Now, all of these individual terms have very specific meanings. Zero knowledge, we're very aware. It's just that we're not revealing any private inputs. Succinct here means that proofs are sufficient enough, they're small and fast to verify. And when I talk about the concept of prover and verifier, in case of zk-SNARK, we are in a trust-based system. That means that there's no interaction needed between prover and verifier with respect to the private input. So there's no sensitive information that we are exchanging between the prover and the verifier. So it's a trusted setup. And when I say argument of knowledge, for every zero knowledge proof, there has to be a concept of soundness that needs to hold. Now, what that means is, let's say if a particular statement is false, a cheating prover should not be able to convince an honest verifier that it is true, except with some very tiny probability. So in case of a zk-SNARK, argument here signifies that this property should always hold within a polynomially bounded time, which means that within a feasible amount of time, there shouldn't be a possibility that the statement is false and the prover is able to prove it correct. So that property always has to hold. And we'll understand how this is implemented. So we know the structure of a zero knowledge proof. So one very simple example of zk-SNARK implementation could be that we start with a very simple hash function, could be any hash function of your choice. Now, instead of doing these exchanges one by one, one after the other, it can be a very computationally intensive operation. So what we do is we basically start with a random seed and then compute the hash. Then we take the hash and keep repeating this process n number of times. And then based on whatever these random numbers that we've generated is, we send this random oracle of numbers back to the verifier where they can verify based on the hash function that they are aware of, if they're able to replicate all of the random numbers that you started and gave back with. So instead of doing to and fro multiple number of times, there's one proof that is generated against multiple different challenges that are thrown by the verifier. And I'm not going to delve a lot into the details of how it operates at a mathematical level, but it's a more sophisticated way of approaching a zero knowledge proof. And why is it relevant? So let's take a trip back down the memory lane to a point where we were stuck with centralized systems and there was no decentralized way of managing money. So the first introduction was probably around DigiCash. There was a concept of e-gold, BitGold, where you could manage your money in a digital format instead of just managing it in terms of currency or keeping it in your bank. 2008-9 is the period where the first time a decentralized way of managing money came in. Bitcoin was one of the first implementation where a decentralized network was supported where you could manage money. Now with Bitcoin, there were multiple different versions of it that came out. There was Litecoin, there was BitShares, but one important application was Zcash, which was trying to add a privacy layer on top of what Bitcoin was already able to provide. But the problem with the Bitcoin ecosystem was that you could just manage money. You couldn't control how and under what conditions. So programmability was missing from the Bitcoin and Zcash ecosystem. And that's exactly where Vitalik entered and introduced Ethereum as a concept where you had the ability to manage funds, but also at the same time had programmability. And while Ethereum has its own issues with scalability and finality times and transaction throughput, there were other ecosystems that blossomed out of those minute problems. There were Cosmos, Polkadot, Near, all trying to solve for either of these problems. But there was no ecosystem that was trying to solve for both privacy and programmability. And that's exactly where Aleo comes in. And how Aleo achieves both of those things together, which is high privacy and high programmability, is through zero knowledge execution. We'll talk a lot about what zero knowledge execution is, what did it change for the ecosystem, and why does it help you build private DApps in a much easier format. But to summarize what I've just said in a very simple and easy to understand way is, if you look at the ecosystem right now, there's privacy preserving ecosystems, but there's no programmability, which is where Zcash came in. We started with public money. We tried and dabbled with a private money providing app. We saw that both of the ecosystems did not give us a lot of control over how and when we could move this. So we added a public dApp building chain, which was able to pretty much support a huge generation of applications, but again, privacy was missing. And this is the gap Aleo tries to fill. So now you can achieve both interoperability and privacy in a single chain, end to end. Now let's look at what is the advantage? What has changed? So there are two very amazing advantages of the Aleo ecosystem. One is zero gas fees needed. And when I say zero, let me explain the whole concept of zero knowledge execution. Now, when I say zero knowledge execution, it's again not a new concept. It comes from the Zcash ecosystem and builds upon the knowledge of the UTXO model that was primarily used in both Bitcoin and Zcash ecosystem. Now, what zero gas fees needed means, there are two concepts that Aleo introduces. There's a concept of record model, and there's a concept of decentralized private computation. Now, both of them basically help you generate your zero knowledge proof off-chain. That means that you can practically have unlimited application runtime because you're not doing any computation on chain. So clearly you wouldn't have any gas fees for that computation happening off the chain. So unless and until you are updating a state on chain, you wouldn't incur any gas fees. So practically speaking, in most of your computationally intensive operations, you can take that load offline, just verify the proof online, which is a standard process and would be hardly any gas fees. And those are the two major advantages. Now, what unlimited application runtime enables is that you can do very computationally intensive tasks. If I were to talk about a very simple example like ZKML, you can practically build linear regressions, classifiers, and heavy computation when it comes to, say, just machine learning. You can compute all of this offline and just generate an on-chain proof to verify the inference of that model, which is something which is not possible in other ecosystems if we look at the current status. Now, another important thing that we see in traditional blockchains is as the number of executions go on increasing, your cost of execution is also going to increase. Why? Because the gas cost is directly proportional to the number of OP codes and all of the other things. How your code gets transpiled. Based on that, your gas cost is going to linearly increase. While in case of Aleo, it's going to flatline. The primary reason for that is because here, the number of executions are not always on chain. It's a combination of off-chain proof generation and using those proofs to generate on-chain states or update certain things on-chain. And that's the beauty of this ecosystem that is able to provide scalability with privacy while still enabling you to have the experience of building on an L1. Now, how is all of this even possible? Now, we know that Aleo is building things from ground up. That means you have your own language, you have your own VM, and there has to be some sort of consensus mechanism that is powering all up. Now we are aware of two consensus. There's proof of stake, there's proof of work. But what Aleo operates on, it's called proof of succinct work. Now, if we zoom out on this ecosystem and look at it, we still have the validators, we still have the stakers. What we are introducing new here is the provers, because this entire ecosystem, it's permissionless, it's private, so it operates completely on zero knowledge proofs. So let's start from the developer perspective. How do you start building on Aleo? You utilize a language that's specifically built for writing these secure applications while abstracting away the difficulties of writing circuits and writing zero knowledge proof generations on your own. So Leo is a language which is Rust-based and specifically designed to help you build private applications. Then there's a Snark VM. Now, similar to how you have an EVM, there's a Snark VM. It's a virtual machine that's powered by zero knowledge. And then we also have Snark OS, which is a blockchain that is secured by the proof of succinct work consensus. So let's look at each of the individual roles and where can you as a developer step in? How can you get started with building? We know there's an infrastructure layer. Leo language is my entry point. How do I get started? So apart from the language, we also have an SDK that lets you build full stack DApps on the Aleo network. We have an Aleo Explorer. We also have a popular application called ZPass, which helps you manage your identity-based authentications on-chain. And happy to chat about it post the workshop or during the office hours more about it. But let me give you a little bit of context on what the language does for you and what has changed. Now, from the perspective of, let's say, just an EVM ecosystem, we all know that once we take a particular Solidity piece of code, I'm going to take that code, convert it into bytecode. Bytecode gets split into all of the OP codes, and then that bytecode and OP codes are processed. Now here, in this case, let's say I have a particular statement. I want to prove that I know the sum of two numbers. So there's variable A, there's variable B, and I'm generating a variable private C, which is not known to anybody. I just want to know I know the sum of the two numbers. So your Leo language is basically going to get converted into virtual machine instructions. That machine code is then going to be understood. The concept of processing is still the same. The new step here that's introduced is the proof generation. Now, once the proof is generated, the VM is going to take that proof, verify it on chain. The validators are going to do that job for you. And then you're going to add the transaction once the proof is valid. Now, a lot of you would be thinking, we've talked about proofs. We've talked about the whole ecosystem that's powering it, but how is zero knowledge execution working? So that's exactly where the novelty comes in. So it's built around a new primitive, which is called records. How many of you here know about UTXO? Maybe you can put a thumbs up in the chat if you're aware what UTXO is. It's basically a kind of model, state model on which Bitcoin as a chain operates. Since I do not see anything in the chat, okay, since I don't see anything, I am going to assume that people are not aware. But let me give you a bit of context. So account model is what is generally used in your Ethereum and Ethereum-based chains, where your account and the balance it has is the global state of the blockchain. And that's how you can understand the state of the blockchain at any given point of time. However, in case of UTXO, UTXO stands for unspent transaction output. It's a model that is derived or inspired from Bitcoin. It's used in Bitcoin. What that means is that every time you are going to do a transaction, you're not just like your global state is not getting updated, but there is another new record that gets generated. It's very similar to spending cash. Let's say you have 500 rupee note, or you have 500 bucks and you want to pay somebody 350 bucks. So you're going to give the entire 500 bucks to that person, get 150 bucks back, and that person will have 350. So in case of UTXO as well, whenever you are spending a transaction, you not just have the final update, you have the unspent transaction, which is your 150 bucks, and the transaction in which money got debited from your account. So there, at any given point of time, if you want to understand the balance of your account, you're going to look at all of the unspent transactions and then take the balance of all that. And that's the global state of your model. Now, why this model was beneficial is because with UTXO, it's much easier for you to control how the transaction and its related data is basically visible. That's how Zcash was able to build a privacy layer on top of the existing transactions. But the limitation with UTXO is that pretty much what you're storing here is just the information about what you're doing. You cannot store arbitrary data. You're not storing state data or just any data of your choice. And that's exactly what the record model enables us to do. You can store any arbitrary data at any point of time. And what that ensures is that any given point of time, you are aware of what the ecosystem has, what your ecosystem state looks like, while still making sure that you're able to control the access of each of the variables within each of this record. Now, to give you a little bit of primer on how UTXO versus account differs, is a UTXO resembles a directed graph of assets at any given point of time. And in case of account model, it's just a sequential state update. So let's understand it with a much simpler example. If I look at Ethereum, let's say I want to send like 8 tokens to my friend Bob. So after the transaction, the state n+1, it's pretty simple. My account is now left with 2 tokens. Bob has 9 tokens, and rest nothing has changed. So it was a very simple state change. But if I have to do the same thing in a UTXO model, I started with 10 and Bob started with 1. So when I do this transaction, I also need to decide where does this remaining 2 tokens need to go. That's where the unspent transaction output comes into place. And every time you do this, there's a new address that's also generated. That's why there's much more control over the visibility and access of each of these variables. Another thing that you'll see here is it's written 1.999. We're just factoring in for network and transaction fees. So initially we started at UTXO 0, but when you are looking at the output, it's not just one state, but there are 2 states. And this can be multiple states if there are multiple participants that are there in the network. And coming back to where we started this entire process is, we as developers know that we have a functional programming language, which is based on Rust, but very similar in readability and usage to JavaScript, is helping you write your Leo programs. is it possible to change the UTXO in Bitcoin by hard fork? I'll take this question at the end. I hope you can wait for the question. I don't want to take that. I mean, it will take some explanation for me to tell you about it. But coming back to where we were, we know developers can start writing programs. But what happens after you've written your program? So the first and the most important thing is whatever you've written, you need to generate a zero knowledge proof for that entire program. So that job is basically done by provers. Now, if you have sophisticated hardware, you can generate that proof yourself as well, or you can delegate this job to provers who will do it for you. So provers utilize the Snark VM, which is the virtual machine for zero knowledge applications. And since this entire process of proof generation is done offline, you do not incur practically any gas. And then Snark OS is basically the operating system that's powering the entire blockchain. And that's where the validators verify the proof that is submitted on chain, come to a consensus. So it uses Bullshark and Narwhal consensus. Will not be delving into the details, but there are a lot of links at the end of this workshop where you'll be able to read more about it. So let's look at how the transaction is actually happening. One very simple iteration of it. So I deployed a particular transaction onto my network. So it goes to my program registry where my Aleo program is lying. So similar to how you have Solidity contracts, here we have Aleo programs. So within my program registry, this Aleo program has basically compiled into opcodes, which are now needs to be processed by my prover network. This prover network is going to generate a proof, and then it goes to the validator. So let's zoom into this part and look at what's happening here. So once I have come here and I have requested for a proof to be generated, I need to make a call. Now, once this call is authorized, we are assuming that we're asking some third-party person to do this job for us and delegating the proof generation. So these compiled opcodes are basically used by provers to generate a specific zero knowledge proof for you. And that proof is basically sent for execution. Now, what this means is this execution then comes back to the validators, which are basically running a Snark OS, which is nothing but the node. And that is the point where they will look at this proof, verify this proof. And once that proof is verified and validators have come to a consensus, the transaction is finally deployed to the network. This is in short what is actually happening. We are aware of the entire concept. If we just remove the prover, it is nothing but what other blockchains do. Provers adding that layer of zero knowledge is what differentiates this chain from all of the other, because we're not just asking you as a developer to generate this proof yourself, but enabling you to delegate this to other people in against incentivization in Aleo credits. That's what this whole network operates on. So you write the application, provers do the computational activity for you by running the application, generating a zero knowledge proof, and the validators basically host the node, host the blockchain, executes your proof, verifies the proof, and then sends the execution back to you where you can consume it either in your front-end client or use it back in your program to do another computation on top of it. But having talked about all of these different things, what can you achieve with Aleo as a blockchain? What are the different applications that are possible with Aleo, and what are the kind of applications we as an ecosystem are also looking for? To start with, I believe DeFi is always a space where innovation can never stop. So anything to do with DeFi, whether it's DEXs, whether it's swaps, whether it's anything to do with, lending, borrowing, leverage trading, it's more than open. Why? Because here you don't have the fear of MEV attacks or front running, because your data is not public. So even if the validator pool is trying to project an MEV attack, the validators are not aware of the input and output variables. All they have to do is verify your proof and not actually execute it. Another important application that derives here is verifiable oracles. Now, in the current ecosystem, there are a lot of applications where we utilize off-chain data. But there are cases where the data that you're utilizing on-chain to make some decision might be sensitive. And you need to make sure that this data is coming from a trusted source. So in those cases, you can utilize Aleo as a blockchain to build these verifiable oracles so that your on-chain applications are sure of the source of the data, and it's basically attested. Another important application in the DeFi space is actually building private and compliant stablecoins. I mean, how many times do we see depegging of coins happening? So it's very important that we're able to provide reliable and financial transactions with privacy that is guaranteed in a similar traditional finance ecosystem. So we need ways in which we can back this ecosystem that we create around a stable coin and all of its operations in a way that we can control who can see how much of it is minted, how much of it is transferred to another person, and how the money is moving. I do see, yeah, Luna Crash is an example of DPEG, exactly. So the idea is to solve for problems that already exist from a DeFi perspective, but that's not where it stops. There are a whole bunch of other applications that it is enabling. To start with, machine learning. ZKML is a field that greatly benefits from ecosystems like Aleo because now you no longer need to write complicated circuits from scratch and manually compile them, take the load of running that entire computation on chain and then using a chain to verify the proofs. You can pretty much do all of that computation off chain and build verifiable proofs for sensitive data, whether it's healthcare, whether it's banking sector, or any data sensitive field. You can benefit greatly from this ecosystem. Gaming is another ecosystem which Aleo has a lot of applications in. So what it does is that it enables autonomous multiplayer games where you're able to have verifiable randomness, and ZK proofs helps you enable that. So any kind of malicious behavior or malpractices can be avoided, and to just improve the experience of gaming much more on many folds. And one other application which I mentioned in the beginning, ZPass, you can build a zero knowledge authentication applications for easy login, checkout experiences, or in general, easy authentication for your applications. Could be integrated with face recognition, just your wallet setup. There are multiple ways you can go about it, but these were just some of the applications that are relevant. So now that we've talked so much about Aleo, let's understand how can you actually get started with building on Aleo. So I'm assuming that most of the people who are here have been able to set up your, let me just take this question. What happens to the off-chain data? Do you guys hold the data or some kind of snapshot, screenshot, or they will be deleted? If not, what exactly? So the data is not persisted off-chain. When you're delegating a prover to generate a proof for you, you decide what, what is the data against which you are trying to generate the proof for. Given that it's a trusted setup, you are sure that no data is going from a prover to a verifier. But when you generate the proof, you are very well welcome to generate it yourself, or you can delegate it to the prover under the pretext that no information leak will be happening from the prover's end. So it's like having a third party delegation for doing a computationally heavy job for you because you don't have the infrastructure. As simple as that. But there's no snapshot, screenshot persistence for regulatory concerns. Hope that answers your question. I would request you to let me put this link in the chat. Actually, the setup. So it's same as the setup link, but for those of you who missed it in the beginning, if you've not done the setup, it's pretty straightforward. You need to have Rust setup before you start installing anything within your machines. Have Leo setup. Install Snark OS because if you are looking to deploy locally, you need to be able to run a local version of the blockchain within your own ecosystem. And please make sure when you're doing this installation, switch to testnet. Otherwise, it will default to the mainnet and you won't be able to do it without the funds. And there are certain common troubleshoot errors that I've put here if you run into any issues with installation. We can use Gitpod. I'm not sure what Gitpod is. Maybe you want to elaborate on your question. What do you want to utilize it for? And for all of those who are doing this on Windows, there's a specific instruction that has been given for setting up Rust, and all of the other setup. You can basically do this in a Linux terminal within your Windows machine, or you can download a compatible terminal that lets you run these commands. You can have a bash terminal to set all of this up. So we're going to do a bunch of things today. We're going to create a new project in Leo. For all of those who are ready with the setup, you can follow the instructions here to create a new project. We'll also do a code along, but this is in general all of the details you need to know if you want to go back and visit it again. So let's get started. Let me open a new terminal. All right, so whenever you have to create a new project, first make sure that you have Leo installed. Just run the Leo command and make sure you're able to see the options that are supported. So if you look here, what we're trying to do is create a new Leo package in a new directory. So we say Leo new, and let's call this project as, let's call it GM World. So we've created a new project. Let me quickly go to this directory. So if you look at it, there are certain directories that are there within this. Let me see the chat. Yes, sure, definitely. Is this better? I'm assuming this works better. So essentially what we want to do is take a simple project, understand how Leo operates. So let me go to the VS Code and open this project. So if you look at it, currently there are a couple of folders. There's a source file, there's a environment file, there's a program.json file. Now, if I go back to the project, there's an outline that I've specified. Now, there are certain components which are necessary. So your program.json file is very similar to how you have a manifest file or how you have essentially a configuration file. So the first program is basically the name of your program. In Aleo, we have programs, and currently the supported network type is .aleo by default. Version is the version of Leo that it is utilizing. You can add a description of your choice, and there's a license. So you have to always make sure that within your main file, whatever program name is specified here has to match with the program name specified in your JSON file, because this decides the scope. And you're seeing that there is a file, there's a main.leo file, which basically has a program named gmworld.aleo, within which whatever we will do today lies. So this defines the scope of your Leo program. And now you'll see something different from what you're used to seeing. Generally, one would expect a function called function here or some sort of function structure. But in Aleo, we have different concepts. So let's first understand some of those basic concepts before we go ahead and execute it. So similar to other languages, statically typed languages, Leo is also a statically typed language, which means that you need to specify the type of the variable when you're declaring it. So there's no concept of null or no type, so that it doesn't default to anything. We won't be discussing all of the types, but only the ones which are necessary for just running the demo today. It supports bool, integers, both signed and unsigned. There's a specific type called address, which is for wallet addresses and public addresses. You have arrays, you have mappings, and then there is a special data type which is called record, which is what enables zero knowledge execution in the first place. Now, record contains component declarations, and that comes with three different things. There's a visibility, which can be public, private, there's a name of the variable, and then there's a type, because it's a statically typed language. And every record always needs to have an owner component, which defines who is the owner of this record, which is nothing but the address of who's owning this. And now comes the important part, which is the function types. Now, we do have functions here, but what's more important here is transition and finalize. So anything and everything that you want to do off-chain, which is your heavy computation or your business logic, is actually defined under transition. Transition can consume records, it can generate new records, or it can change the record states. Now, what if you want to do something on-chain? So you utilize finalize. So this is the code for on-chain computation. And finalize function is always ran right after a transition function, needs to have the same name as a transition function, and it should always immediately follow. I mean, because once the finalize function gets executed, it looks at what the transition function has generated, against which the state change will happen on chain. Now, what if you also want to do like bunch of other stuff where I do not want to update my state or nothing to do with records? These are just helper functions. So function is where you can write all of your utility code. So it can be called within a transition, can be called within a finalized block, or can be called within another function as well. And we also have inline function, which can be called again within a transition, finalize, helper, or inline function. So these basically help you do all of the utility basic work. So coming back to where we were, what we are trying to do here is that we want to add two numbers and give the output back. Given that one of my inputs is public, but the other input is private, and I'm also keeping my output as private. So in case of Leo, by default, all of the variables are going to be private unless you specify this modifier. So if we go by the syntax, you basically define the visibility followed by the name, followed by the type. So if you see here, even if I'm defining the variable C, I have to specify the type explicitly, and then I return C. So what exactly happens when I execute it? So let's go ahead and say that I want to run my main, because that's the name of my transition function. And if you look at it, it takes two inputs. So let me give 1 and 2. So it's correctly able to give me 3. Now, if you see here, I've actually run the function. I've not executed it. And there's a difference between the two. Just a moment. So if you look here, there are two things that we can do here. Either we can run a program with input variables or execute. What's run going to do? It's just going to build the program for me and run it. It's not generating a transaction object for me. So in order for me to generate that and also make sure that, I'm able to verify the proof that the previous step would have generated, that's where I would utilize execute. Given in this case, I do not have a finalize function. Even if I execute it, it won't make much of a difference because I'm just doing an off-chain computation. Essentially, the output, you will be able to see this whole block that gives you the ID, what was the transition that was done, what was the proof that was generated for this off-chain computation. But since there's no verification happening, the output is pretty much the same thing. Now, this is a very, very simple example. We're just adding two numbers. So let's do something more realistic. Let's go ahead and generate our own token. Token of our choice. So to follow along and to generate your own token, you can go to this file _create your own token and follow the process here if you're losing track while I'm speaking. So what you want to do is create your own version of say a mini version of a token where you can mint as much token of your choice and you're able to transfer it to somebody of your choice. So in order for us to do that, we're going to utilize the record object. Now, what record enables us to do is that it's able, firstly, we need to define who the owner will be. That is able to decide uh, who can mint the token. And then you can have any number of input variables associated with this record. I'm keeping balance. There's also another variable within this token struct, which is called nonce. You do not need to define it. It's implicitly added. We'll see it once we start running the application. So the first thing that we want to do is define a mint function. Now, mint function will be a transition function because when you are minting it, we don't need to do anything on chain particularly because it's a private mint. Unless it's a public mint, we'll basically have a finalized function that will follow it. So what my mint function is going to do is it's going to take the owner who is minting it and how much amount is it minting it. And the output of my transition function is going to be a record. Because it's based on the UTXO model, I need to create a record which can later be consumed whenever I'm trying to send this minted money to somebody else or maybe multiple people. So what I'm returning in as an output is the owner that got passed on from this function and the amount. So let's go ahead and look at this in actual practice. You can simply go ahead and create a new project. I've already created one, so we'll utilize that. So I've created a token called token F3VC. We'll comment this down because this is the workshop part for you. But I've taken a record. To look at it, the program scope is defined by token F3VC. I've created a record token. I have two types. And in my mint function, I'm just taking both of these variables and returning the token back. Now, if I execute it, I'll just execute it again. I had 100 tokens. Let me just go ahead and mint some more. Let's go ahead with 150. Let's maybe go 1500 and be rich. So if you look at it, the output is actually a record where the owner is my address, the one which I had passed as an argument. This is my current amount, and this is the nonce that I've received. And the nonce is basically to make sure that every record is unique that is generated and consumed. And you'll also see that after each of these variables, there's an access modifier. So owner and amount both are private by default because we did not define any public access modifier here. So once we'll deploy this program on chain, you'll be able to see that things which are private won't be visible without sharing the view key with someone. So what's the workshop today? What is it that I want you to do? What is it that I want you to do during the workshop? I want you to write your own transfer function. The job of the transfer function is to take the amount of tokens that I want to transfer, the address that I want to transfer, given a particular record. Because instead of consuming the state, you here actually consume all the unspent transactions, which is nothing but defined by the current record. So you take all of these three arguments and return both the spent record and the unspent record. So recipient here, I mean, you can change the names, but just to give you a little bit of hint, recipient here means whoever you are sending the money to. So it'll be the debit transaction. And sender is what is just left with you in general. So let's say, let me show you how the function will actually look like. So we have function transfer. So we say, let me just go to the previous one. So I'm going to use this record instead of the previous one. So if you look at here, it says Leo run transfer, and then there's a record. This is the address that I'm sending it to. This is the amount. So I'll just update this record because it's the old record, so it won't be valid. Then I'll just copy the address Okay, I think I did not close the brace. So the record format was invalid. Am I still missing something? Oh, okay. I just did not copy it correctly. Let me run it. So we have the record first, and let me just copy the address again. So you can basically try it out with any address of your choice. And we'll just send it 100 tokens. So what you see as an output here is two records. One is what is left with you, which is 1400. And then the new record, which is what we have sent it to the other person. So if you see, this is the address that I had sent it to. This is the record for that address. And that's the assignment that you have. And that's not all. You'll also have to deploy this transaction or deploy this program. So let's understand, how can you deploy a particular program on Aleo? All of the instructions on how you should test it, how you should, what your function should look like is present in this README. So please go through it and make sure that it's a functional program to be eligible for the reward. This workshop is for 3 points, so that will be counted towards your total points. So let's understand the deployment part. Now, there are two ways you can go about it. 6 points. Sorry, thanks for correcting that, Annie. So in order for us to deploy this particular program, what we are going to utilize is, we need the Leo wallet. So Leo wallet looks something like this. Let me. So your Leo wallet will have an address similar to how you have other addresses. And in order for you to be able to deploy a program on Leo, you need some test tokens. Now you can get test tokens. You can follow this guide. Basically, you need to go to the Discord, request for some test faucet, and you should be able to get it within like a few minutes. I'm not sure, Hemant, what issue you are running into, but I did get test tokens like probably like an hour ago. So it is functional at the moment, but if you do run into issue, you can always message me on Telegram or also seek for help on the Aleo Discord if you're not able to get the resolution. But the process to deploy a program is pretty straightforward. Perfect. We need a couple of things. Since the entire Aleo ecosystem is driven by the program and the program's registry, the deployment also happens through the program ID itself, because that's the uniqueness of your of whatever you're putting out. So what we're going to do is we're going to create a script of our choice. Let me show you that script as well. Just a moment. So ideally, what we want to do is we want to take this program token F3VC. We say that there are various functionalities within Snark OS. So we are going to utilize deploy. We are going to pass our private key. You can get your private key from your Leo wallet, or you can create a new wallet using, let me also show you how you can create a new wallet if you do not want to if you do not want to utilize your, just a moment. So you can also get a new pair of wallet by just creating multiple accounts. So you can utilize this address, private key address pair, and fund this wallet and go about it. Just Leo wallet helps you manage your funds much more easily. But what we're trying to do is since we need to sign the transaction, we need the private key. We need to specify the explorer against which it will match the current status of the chain, look at the current block. I've kept the priority fee as 0, but if you have more credits available, you can add some priority fee so that your transaction gets added to the block a little bit faster. Then you need to specify what is the program that you are deploying. So that's why the program ID. We need to specify the path where our artifacts are. So we have the AVM files, the compiled files, everything that was generated that transpiles the code into a bytecode. That is something that it needs access to. And then broadcast is the path where your transaction is eventually going to be added and where you can view it. So all we need to do is just deploy this particular transaction. I think I did that a couple minutes ago, but I can do it again if it's not here. Okay, I did deploy it a couple minutes back because sometimes it takes longer. All you need to do is just execute this particular transaction. And if you have enough funds, when you request for funds for the first time, you'll get enough funds. Your transaction will basically be added. Some of you might face an issue when you are trying to see your transaction, but as long as you're able to see the transaction here within your Leo wallet, that should do. Some of you might run into this error where the Explorer is out of sync. That is okay. What I would need from your end, which will count as a valid submission for this workshop, will be a complete Leo program, which is essentially this program, which has the transfer function implemented. You need to submit this in form of a GitHub repo. And within your README, you also need to provide me the screenshots that your function was executing. And at the same time, you also need to provide me a screenshot of the deployment and a link to this deployment. So if you click on this particular deployment, you'll be able to get a link. So you need to provide me this transaction ID or just this link. That is what the requirement is from a submission perspective. But just coming back to where we left off to make things a little bit coherent, I think there are some questions. View key is like a public key in EVM? No, view key is not public. You can utilize any wallet of your choice. You can use Puzzle Wallet. No restrictions there. View key is basically something that you can share on a need basis. You still have a public key and private key. Let me go back and show you a transaction on Aleo. Let's just pick the first transaction that comes up. So if you see here, there are 3 things that you have. One is the address, which is this, which is your public key. Then there's a private key, which is basically being used for signing the transaction, right? This is your public key. Then there's a private key that was used to sign the transaction. And then there's another concept called view key. This view key is something that you can share based on who needs to view the private data. For example, your accountant needs to see your transaction, or in a particular application, you have a trusted source of people who can be your in a multi-sig setup, you would want some people to be able to, help you recover your key in certain cases. So those people will need to have the view key. View key is basically for reviewing the private inputs/outputs that are there when you are generating a record or consuming a record. So it's not the same as public key. Hope that answers your question. All right. Coming back to where we left off. Let me get this out of the way. All right. For those of you who did not make a note, this is the setup link. You could if somebody is not able to do the setup in the computer, you can also do it on Aleo Playground. You can get a feel of Leo on Aleo Playground. But if you want to submit a submission for this workshop, you will have to do the setup within your system. Income tax will use view key. No comments here. But yeah. These all the links that are there within the presentation as well. But to give you a closure on where we are at as an ecosystem. We are open to supporting developers who are building something on this chain. There's a form that you can scan this link, scan this form, send us what you're building, and the ecosystem tries to support the projects who are building and looking at if your project, what kind of support you need, whether it's an ecosystem support, marketing support, developer support, depends on your use case. Apart from that, we also have bug bounty programs for our SnarkOS and SnarkVM infrastructure. And Aleo keeps organizing a bunch of different hackathons. So, if you do find us at the events you're attending, come and say hi. Apart from that, all of these useful links are basically linked for you. So you can scan this QR to keep this slide handy with you and refer to any of these resources that are there. And for all of the submissions that you'll do for your workshop, Annie has also posted the link in the chat, but you can just remember this tinyurl.com/submit to earn so that you're eligible for the participation. And that's all I had for today. You can scan this QR for important links. And if you are someone who loves to read about Web3 and keep themselves updated, you can scan this QR to subscribe to my Web3 newsletter. I write about trending Web3 topics and in general try to make this feel a little bit easier for everybody who's following. And thank you so much for being a lovely audience. I'm open for any questions that are there. You can either unmute or ask it in the chat. You'd love to know how did I get into Web3 and my journey? For me, primarily it was through hackathons. I was actually an ML engineer and I started building my first application that was a combination of ML plus Web3. And I happened to build a project that was built during a hackathon where Government of India had a problem statement. And that's something that made me, I think, aware that there are a lot of problems in the machine learning space that can be solved through Web3. So I started going to more hackathons, started building more problem statements, then started exploring the Ethereum ecosystem. I started through Hyperledger. Back then, MetaMask used to be very, I would say, very crude, not the kind of advanced MetaMask that we see today. So the integration was not very intuitive, but the application and the kind of protocols that were there were building like from the base up. So my journey was more about learning, experimenting, implementing, building projects. And that kind of brought me into this space. I did disconnect from this space for a while I was working in the fintech space. So I came back in Web3 ecosystem somewhere in the end of 2021. Yes, I am from tech background. I have around 5 years of experience in the tech space. I've worked with different ecosystems. I worked in the ML space, worked in software engineering as a backend engineer, full stack engineer. And that kind of like the experience in fintech gave me a lot of insight into why Web3 as an ecosystem can solve so many recurrent problems in this space. And I currently work in the DeFi space and work with Aleo as a DevRel ambassador. So ZK is a space that's always close to my heart. So I love the innovation that's going on there. And yeah, that's a glimpse of where I started, where I am now in my journey. But happy to answer any more questions if you have regarding the workshop, any doubts with respect to what the workshop, what the submission requires, or in general about what you're required to submit. Happy to answer any questions that are there. In case there are no questions, I'm assuming I was pretty clear in what needs to be done, and I think that's the best thing. A little bit of JavaScript. How do I get into dApp development? If this question is specific to Aleo as an ecosystem, I think it's very easy because the Leo language, though it is Rust-based, but it's more from a security and speed perspective, the implementation and the readability of it is very similar to JavaScript. So your experience of development is not going to change when you are building secure dApps. And the good thing about the ecosystem is that you have an SDK. So all of the components which come in with respect to wallet connection, integration, state management, or things like ethers.js integrations that you are used to in Solidity space, you can do all of those things through the SDK. So DApp development requires two things. One is building the backend, building the contracts, building the programs. And then there's a front end aspect to it where you need to write some client. So in case you are starting out early, what you can do is you can utilize third-party SDKs, which give you a front end where you do not have to spend a lot of time building the front end for your dApp if you're good at building the backend aspects. And mind you, backend does require you to utilize a lot of JavaScript/TypeScript, depending upon what stack you're using. But with front end, you can use pretty much any stack. If you're coming from Mern stack, you can use pretty much anything. Perfect, Mern stack. So you can use React for your front end, and within your backend, you can use Node.js, Express.js, anything that you're comfortable with. So with dApp development, you have to be sure that the skill that you need to acquire is the integration. How do you integrate the smart contract state management? How do you send that response back to your front-end client and handle those responses? So that is the only thing. And for that, there are n number of JavaScript libraries that are out there that let you do that. Aleo itself has a very exhaustive SDK. So if you want to build something on Aleo, the first thing that you'll have to do is deploy your program, deploy your Leo program, and then start interacting with that Leo program on chain. The instructions to start interacting with your program is also there in the README file. So please go through the workshop repository properly to get a proper idea into how to deploy a program, how do you interact with that program. There are relevant screenshots for you to look at and just get a hang of what it looks like. And if you do end up getting stuck at any point, you can actually ping us or anybody on either the Discord on Aleo, or you can drop a DM or a message on the F3 Telegram. I will be open to responding any queries. And just a quick question to the group who's already here. How many of you actually have the setup done for your, how many of you have Leo and StarQuest already set up in your systems? Maybe a raise of hand if you have access to, or maybe like you could type a yes in the chat. Just trying to gauge how many of you are ready to kind of get the ball rolling. Perfect. It crashed twice. Maybe Melissa, you can elaborate on what actually crashed. Was it the installation of a specific element? You're trying on Windows. Okay, I'm assuming the Rust setup is crashing for you. Was the Docker. What I would suggest you go ahead with, like if you look at the setup installation, instead of Docker, I would suggest install a Rust based on what installation instructions are there, and then download a bash terminal for your Windows ecosystem and follow the steps similar to what you would follow for Linux or Mac OS. That's the best way. I mean, I've tried the Windows setup. The Docker setup is only for cases where you are not able to do it with any of the other steps, because sometimes the Docker image is down, or whoever is maintaining it, there's a downtime to it. So in those cases, I mean, if you are able to like send me a detailed stack trace of what issue you're running into, I might be able to help you in more detail, but would suggest you go ahead with installing Rust first, and then trying to install your Snark OS and Leo actually through your terminal itself. And for ease of access, Git and Rust are installed. Would suggest you to download a bash terminal within your Windows system and try the setup instructions through Cargo itself to install your Snark OS and Leo. I can send you the link for bash terminal for Windows as well. This is a good guide. just sent you a link. You can follow this along. Have a bash terminal setup and then install all of the other things as usual. You install everything in Debian first. Leo and StarkOS, okay. Maybe Melissa, you can drop me a note with your entire setup, like what all you did and where you were actually stuck, so I can help you with more detail. But I do see Gitpod is something that was able to help. I haven't used it before, but I'm assuming it's a development environment of sorts. So we'll probably check it out as well. Also him, I'm not sure who typed it, but Gautam, if you do have a link that can help, please feel free to drop it here or on the Telegram so that it can help others who are trying to do it on Windows. Perfect. If there are no other questions, I think that's the end of it. Thank you so much for joining, and I hope you were able to learn about Aleo, and I look forward to seeing your programs deployed on Aleo and see what projects you end up building. Thank you so much.
Thank you so much, Laisha, and thank you everyone for participating for a very successful day one of Builder. And tomorrow we have 3 more really amazing workshops, so please mark your calendars. And also a reminder that all points have been doubled, so your crypto rewards and entries into the grand prize, a all expense paid trip to Bangkok, Thailand to attend DevCon will be higher. So see you all tomorrow, and thank you for all your hard work. Oh, and yes, and all the points carry over. So you still have lots of time to get more points for more crypto rewards and more entries. Okay, thank you. Bye-bye.
Thank you.